Okay, we will do the question. And this is the question, and it is question number 2 of your assignment 1. Okay, so it is related with DFT, discrete Fourier transform. Okay, so we will try to do this. Okay, so discrete Fourier transform. Okay, so here we are given a sequence. Okay, it is given as a impulse train, no? Okay, so if I draw the impulse train, it will look like this. This is N, and I'm going to draw this impulse train. Okay, so this is the zeroth impulse, delta N. So you have to here. Okay, and we have 1, 2, 3, 4, 5 up to infinity. Okay, so this is the zeroth one, and so this is delta N minus 1. Okay, that means it is shifted to 1. Okay, in this direction. So we have here another impulse, that is 3. Okay, so here N minus 2, that means this point we have minus 1 impulse, so it will be minus 1, and 3 there is no impulse, 0. Okay, so here we have in minus 4, that means here we have another impulse, that is plus 1. Okay, so this is our impulse. So if I write the sequence, it will look like this, no? Okay, so here we have 2, 3, minus 1, 0, plus 1. Okay, so this is our sequence. Okay, so we are asked to find the 4-point DFT. Okay, so I think you can remember the definition. Okay, so definition will be so xk. Okay, this is the discrete Fourier transform of xn. Okay, so n is 0 to n minus 1. Okay, xn e to the power minus j. Okay, so we have 2, 5, n. So this is n, that is actually number of samples. Okay, so here it is said that we have to find 4-point DFT. So this n should be 4. Okay, and we have k here. Okay, so this term will be equal to omega actually. Okay, so we have n also here. Okay, and this k normally from 0, 1, 2, 3, so on up to n minus 1. Okay, so this is the definition for endpoint DFT. Okay, this is the definition for endpoint DFT. Okay, so we have to use this actually here. Okay, and okay, now if we try to find the 4-point DFT for this sequence, you can see that here we have 1, 2, 3, 4, 5 elements. Okay, so the length is not 4 actually, length should be 5. You know, this length should be 5. I think here it is a mistake. Okay, this length should be 5. Okay, so think of it, maybe this 0 may be not considered. Okay, but I think we have to consider this 0 also. Okay, so here we have 5 points length. Okay, actually if the length is 5, this 4-point DFT is not enough. Okay, because the n number of points or number of samples should be greater than or equal to L. Okay, the length of the sequence, this L is the length of the sequence. Okay, and if not, we can't recover the xn we can't recover the xn time domain sequence from this sample. Okay, from this number of samples, we can't recover this xn. Okay, so at least you have to find the Fourier transform of 5 point DFT. Okay, so normally actually we are not going to calculate 5, 6 points so on, because it can add some calculation complexity. Okay, so the calculation will be difficult if we use this kind of points. Normally this points is a number of power of 2. Okay, that means 2, 1, 2, 2, 2, 3, so on. Okay, that means 2, 4, 8, 16. Okay, so we are mainly focusing on this kind of samples, number of samples, number of point. Okay, those should be 2 to power value. Okay, 2 to the power value, and it will be easy to calculate. That is the reason. Okay, so it is possible to calculate 5 point, 6 point, anything, but when we are calculating, if we use this kind of 2 to the power value, it will be easy for the calculation. Okay, I think we can understand when we are doing the FFT, okay, we can get a clear understanding when we are performing the FFT, I hope. Okay, so here anyway, so we can calculate the 4-point DFT, no issue. Okay, we can calculate the 4-point DFT. Okay, then we will get some what is frequency domain samples. Okay, we get some frequency domain sample here. Okay, so there should be 4 sample actually, x1, x2, x3, x4, so on. Okay, so you can try if you perform the IDFT. Okay, IDFT for this frequency domain sample. Okay, I think you can understand what I'm saying. Okay, so here we have a time domain signal xn, and we are, so here the length is equal to 5. Okay, okay, so here we have, okay, here we have xn. Okay, time domain sequence. Okay, so here the length of the sequence is 5. Okay, now if we perform 4-point DFT, okay, if we perform 4-point DFT, we will have some samples, frequency domain samples. Okay, frequency domain sequence. Okay, so we will have 4 samples only. Okay, because we are performing for DFT. Okay, so we will have this kind of sample. Okay, okay, so if you perform the IDFT, again, we should have this xn. Okay, after IDFT also we should have this xn. Okay, with L equal to 5. Okay, so you can try this. Okay, so we are going to perform this one. Okay, up to this one. Okay, and I think as exercise you can try to find the IDFT of this xk. Now we are going to find the xk. Okay, so you can perform the IDFT on this xk and check you can recover the xn. Okay, so I hope we can't recover the xn actually, because we are going to find 4-point DFT. Okay, but the length is 5 of this sequence. For this 4-point DFT, not enough. Okay, so you can verify it. Okay, and if you can let me know the result also. Okay, so we will move on to our question. Okay, so we have xn. Okay, xn is 2, 3, -1, +1, -1, 0, +1. So this will be our xn, no? 2, 3, minus 1, 0, plus 1. Okay. Now our xk will be, okay, sigma n equal to 0 to, normally we have to take n minus 1. N minus 1 means we have to calculate up to 3. Okay. So here we have to calculate up to 4. So I will put 4 here. N equals 0 to 4. Xn e to the power minus j 25k n. Okay. So this is for our case. Okay. So this L should be 0, 1, 2, 3. Okay. This K, because we are going to perform 4-point DFT. Okay. So our K should be 0, 1, 2, 3. Okay. So this is our K value. Okay. Now I think it is very clear, very easy to find the xk value. Okay. The frequency domain sequence, actually that is the frequency domain samples. Okay. So we are getting the samples in frequency domain. That is the purpose of DFT. Okay. So if I write this xk, okay, so we have x0, x0 means 2, e to the power j to 5k, n is 0. Okay, so e to the power 0, so you will have 1 here. Okay, so I directly write it as 2, 2 into 1, again you have 2, okay, plus, and now x2, okay, x2 is 3 actually. Okay, so we have e to the power minus j 25, sorry, this is not k, this is n. Okay, so this is n. In our case, this n is equal to 4. Okay, so we have 254. The n is 1. Okay, so plus x3, x3 is minus 1. So this will be minus. Okay, so this sign will be minus 1 e to the power minus j 25 by 4. Okay, so this is 0, 1, 2. Again, there is no value for 0. For n equal 3. So we have 0 there. So I'm not going to write the 0 there. Okay. So my next component will be x4. X4 is 1 again. So we have 1. Okay. So because it is 1, I'm not going to write it. Okay. E to the power minus j 25 by 4. We have 4 here. 0, 1, 2, 3. No, we have 4. Okay. So we know the k value. K value is 0, 1, 2, 3. Okay. So we have to find this k value. Okay. So it is very simple actually. Okay. So you can calculate x0. Okay. So x0 will be 2. Okay. Sorry, I forgot the k value here. Okay. So here the k should be here. Okay. Here we have k here. Okay. And here also k. Okay. K. And here also k. I will write it in the color k. Here also k. Okay. I forgot to write this k value. Okay. So k is there. Okay. 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 So we have when x is 0. Okay. So we have 3. E to the power k is 0. That means e to the power 0, it will be 1. So it is only 3 minus e to the power minus j 4, 2, 5k again 0. Okay, so it is only 1 plus e to the power 0. So you have 1 here. So the answer will be 5, no? Okay. So the sample is 5. Okay. So if you find x1, capital X1, you will have 2, 3, e to the power j, 2, 5 by 4, k is 1, and here you have 1. So it is 2, 5 by 4, minus e to the power minus j, 2, 5 by 1. Okay, so here you have 2. Okay, so you have 2, 5 by 4, 2, plus e to the power minus j, 2, 5 by 4. So you have 1 here. Okay, then 4 is there. Okay, so here, so you can see that these are some complex value. Okay, these are some complex value. So you can simplify this further. Okay, so the method I will follow is that normally I will convert this polar form complex number into Cartesian form. That means x plus iy. Okay, so you can use the Euler formula for this one. Okay, and you can find the value. Okay, then I can add all together, so I will get this kind of complex number. Okay, if you need, then you can again convert this to a polar form. Okay, so that is the process I know. Okay, I don't know whether there is any method to simplify this within this polar form. Okay, I don't know that kind of method. Okay, so if it is if that kind of method is available, you can use it. Okay, no issue. Okay, so this is the way I am going to measure it. Okay, okay, now the problem is that how to convert this to a Cartesian coordinate. No? So the first method is you can use this one. Okay, you can use Euler formula and you can convert them into Cartesian form. The second method is if you are in home or if you are doing a real analysis. Okay, for engineering design, you no need to do this calculation by hand. You can use Matlab very easily. Matlab or any mathematical tool to calculate this value. Okay, otherwise you can use you can use the definition of the complex number. Okay, complex number. Okay, so that is also somewhat easy. Okay, this method. Okay, so we will use this one. Okay, we will use this one. Then actually using this one also we are doing the same thing. Okay, we are doing we are converting this polar form complex number into a Cartesian form. Okay, the same thing you can do using the Euler formula. Okay, using the Euler formula. Okay, but I am going to use the basic definition here. Okay, so I think that is somewhat easy. Okay, because we can calculate the value very easily, but not in all cases. Okay, if it is 4.8 point like that, it is easy to calculate the value. Okay, so the method is that I think you already know that it is normally standard method. When we are calculating the Twiddle factor, I think that is the standard method. Okay, so you can see that here we have 2, 5 by 4. Okay, we have 2, 5 by 4. Okay, that means we have divided 2, 5. We have divided 2, 5 angle into 4 equal portion. Okay, we have divided this circle into 4 equal portion. Okay, so this 4 is the number of portion we should have. Okay, so that is the DFT number, actually sample number. So if it is 8, we can divide this circle into 8. Okay, so if I divided it to 4, okay, so you know that 2 5 by 4, it is 5 by 2, that is 95 5 by 2 degree. Okay, so this will be my first position, and after 90 degree I will have one position. Again, after from here, again after 90 degree I have another position. Here I have another position. So these are the 4 positions I have. Okay, when I divide this circle into 4 equal parts. Okay, so this should be a the radius should be 1. Okay, radius should be 1. Okay, radius should be 1. Okay, so this is okay. So you can see that this will be, you can mark as this is the 0th. Okay, and this is the first. No, that is not the first one, because we are using the minus sign here. Okay, we are using the minus sign here, so we have to go in this way, minus direction. So this is the first one. Okay, and this is the second one, and this is the third one. Okay, so this is 2 5 by 4 0 level, 2 5 by 4 1 this point, 2 5 by 3 this point, sorry, 2 5 by 4 this point, 2 5 by 3 this point. Okay, so sometime you may calculate, you may have to calculate 2 5 by 5, 2 5 by 4 5. Okay, so you have to go through this circle only. Okay, so this will be 0 1 2 3, and this will be again 4 5 6 7 8 9 10 11, likewise you can go through this circle. Okay, so you can calculate all the values using these circles. Okay, so this is actually the complex plane. Okay, so this is the complex plane. So this will be the real axis, this will be the imaginary axis. Okay, so you know that imaginary axis we have J. Okay, so this so we are choosing, we are choosing radius as 1. Okay, so this point will be +1, this point will be -1, this point will be, so this point is in imaginary axis, so it will be +j, and this point is in imaginary axis and it will be -2. Okay, so you can calculate all the points. Okay, so I will use this one. Okay, so we have x1. Okay, that is 2 plus 3 e to the power minus 2 5 by 4 1. Okay, so here 1, we have 1. Okay, so that means this is the point. Okay, so you have minus j here. Okay, so here you have minus j. Okay, 3 by minus 3. Okay, so here minus, here you have minus j 2 5 by 2. Okay, 2 5 by 4 2. Okay, so that means this point 2, it will be -1. So -1 -1, you will have +1 here. Okay, plus, so you here you have e to the power minus j 2 5 by 4 4. Okay, so here you have 4. So I calculate is 0 1 2 3 4. So again it is this value, so that is +1. Okay, so here you have +1 and +1, you will have +1. Okay, so this is the value for x1, that is 4 minus 3j. Okay, so we will verify the answer using the Matlab. Okay, so I will use this command window. Okay, so you can see that if we write like this, okay, xp minus j. So I will write it as 1i. Okay, this is the standard method uh, to type the j minus j, the complex imaginary parts j. Okay, you can use 1i. Okay, you can use the j also, but Matlab asks to write the j in like this. Okay, I think not j, you have to put I. Okay, okay, so you have 2 pi. Okay, 2 pi, and you have to divide it by 4. Okay, you have to divide it by 4. Okay, so if you see this, okay, so you can see that it is 0.00 minus 19. So you have this Cartesian coordinate here, no, as the answer. You will get directly Cartesian coordinates value. Okay, so it will be minus I. Okay, minus j in our case. Okay, so we will see it. So this is the first point, no? So this is the first point. So this is 0, 1. Okay, so it will be minus j, no? It is minus j. I think it is correct. Here we have minus j. Okay, so if I write these all terms, okay, let me write these terms. Okay, so I have 2 plus, okay, exponent, this one, no? Write it. This is 2 plus, okay, exponential minus 1i 2 pi divided by 4. Okay, so I will copy this one. Okay, I will copy this one divided by 4. Okay, then I have okay. Okay, so I have so now I am calculating x equal 1, so 2. Okay, so 3 e to the power minus j to 5 by 4. Okay, then we have to type this one, that is minus. Okay, so here it will be minus minus 2 5 by 4 by 2. Okay, so 2 5 by 4 by 2. Okay, so I will put 2 here. Okay, so we have 2 5 by 4 2. Okay, so this term I write. Okay, I have written this term. Okay, so next I have to write this one. Okay, so it will be plus e to the power minus j to 5 by 4 4. Okay, so here it should be multiplied by 4. Okay, so let's find this value what we get. Okay, so we have 4 by minus 3 I. What's happening? It should be 4 by minus 3 I. What is the issue? Okay, I have write this one 2 plus 3 e to the power. Yeah, I have missed 3 here. No? Okay, so I have to type the 3 here. Okay, so this term, which term? This term, this term will be multiplied by 3. Okay, so this term, okay, 3 e to the power j to 5 by 4, that is okay, this term. Okay, okay, so that is this term, that is okay. I think 3 e to the power minus j to 5 by 4, that is okay. Then minus this term, I'm going to write this term, minus e to the power minus j 2, 5 by 4, again 2, that is okay. And the plus this term, e to the power minus j2 5 by 4, 4. Okay, I think correct, no? Yes, we have 4 minus 3i. Okay. So likewise, you can get this value. Okay. So if you want to find x2 here, okay, what you have to do is you have to add, you have to substitute 2 instead of this k. Okay, instead of this k value. Okay, so it will be 2 plus 3 to the power e minus j2 5 by 4, k is 2. Okay, so we have 2 plus 3 e minus j2 5 by 4 e to the power 2. Okay, minus e minus j2 5 by 4, k is 2, and here you have this term, k is 2, 2. That means you have 4. Okay, plus e to the power minus j2 5 by 4. Okay, 2 5 by 4. The k is 2, and you have 4 here, 4 here. So you have 8. Okay, you have 8. So you have these terms. Okay, so if you simplify this one, you have 2 plus 3. So e to the power minus j2 5 2. Okay, so you can use this one. So this is 0 1 2. 2 is minus j. Okay, 2 is minus j. And sorry, not minus j, minus 1. Okay, so you have 3 minus 1 here, minus e to the power minus j2 5 by 4. So that means 0 1 2 3 4, this part. Okay, so it will be plus 1. Okay, so here you have minus 1 also, because minus 1 plus 1, you will have again minus 1, plus e to the power minus j2 5 by 4 8. So you have to find the 8 point, the 80th point. So you have 0 1 2 3 4 5 6 7 8, correct? 0 1 2 3 4 5 6 7 8 8, this. So it will be again plus 1. Okay, it will be again plus 1. Okay, so you can see that this one will cancel out. Okay, and here you have 2 minus 3, that means minus 1. So your x2 will be minus 1. Okay, quickly we will see using Matlab. Okay, so here you will have instead of 2 5 by 4, you have 2 here. Okay, you have 2 here, and minus e to the power 2 5 by 4, you have over here, and plus e to the power minus j2 5 by 4 8. No? So you have plus e to the power minus 2 by 5 8. So if you calculate this value, you will get minus 1. Okay, correct. You will get the minus 1. No? Minus 1 cancel out. 2 minus 3, we will have minus 1. Okay. So we have the same result there. Okay. Likewise, you can calculate the x3 is not there, that is 0. Okay, and you can calculate x4. Okay, you can calculate. No, you have to calculate up to this. No, sorry, x3 will not be 0. Okay, I'm sorry, x3 will not be 0. You have to calculate this x3, capital X3. So you have 2 plus 3 e to the power minus j2 5 by 4. Here 3 into 2. Sorry, 3 into 1, you will get 3 minus e minus j 2 5 by 4. Okay, here you have n is equal to 0 1 2. Okay, So 2 by 3, you have 6 here, plus e to the power minus j 25 by 4, you have 4 here. So 3 into 4, you have 12. Okay. So if you calculate this value, you will have 2 plus, this is 3 5 by 4. So 0 1 2 3. So this value, it will be plus j. So you have j here, plus j, minus e to the power minus j 2 pi by 4 6. Okay, so you have to calculate 0 1 2 3 4 5 6. You will have minus j. Okay, 0 1 2 3 4 5 6 minus j. So here minus, then you will have minus j. Okay, for this term. Okay, plus e to the power minus j 2 5 by 4 12. So you have to calculate 12. 0 1 2 3 4 5 6 7 8 9 10 11 12. This point, no? 0 1 2 3 4 5 6 7 8 9 10 11 12. So this point, so you will have plus 1 here. So you will have plus 1 here, correct? Then if I simplify this, I will have 3. So here minus minus j, so plus j. So you will have 3 plus 1. So you will have 4j. Okay. So let's check the Matlab. Okay. So I get this one. Okay. So I have 2 here. Okay. So in this point, instead of this 2, we'll have 3 here. Okay. And the next term minus x e to the power, you will have 6 here. Okay. So this will be 6. Okay. This will be plus e to the power minus j 2 5 by 4 12. So you will have 12 here. Okay. So if I calculate that, it is 4 by 3i. Yeah, it is 4 by 3. I know I have written here wrongly. Okay, so you can see that 2 plus 1, you will have 3 plus 3j minus 1. So you will have 4j. Okay, so you should have 3 plus 4j. No. What is that? Okay, I think we have a mistake. So this is 2 pi by 3 minus 2 pi by 6 plus 2 pi by 12. I think this is correct. I think this one we have mistake. I will calculate it again. Okay. So here we have 2, this 2, and this will have 3 e to the power minus 3. So you will have 0, 1, 2, 3. So it will be plus j. That is correct. No, plus j. So here you have minus e to the power minus j 2 5 by 4 6. No? Okay. So here 6. We have to calculate 0, 1, 2, 3, 4, 5, 6. It will be minus 1. Yeah, this is the issue. Okay. So here I put minus j. It should be minus 1. No? It should be minus 1. That is the issue. Okay. Because we have to calculate the 6th point. Okay. We have to calculate the 6th point. Okay. So 6th point is 0, 1, 2, 3, 4, 5, 6. This point. This is the 6th point. Okay. So 6th point is, this is you can see that this is a real axis. This is the real axis. So this will be minus 1. Okay. I have mistakenly put it as minus j. Okay. So it is minus 1. Okay. So I think this one is also correct. Okay. So we will have 2 minus 1, that is plus 1, 2 plus 1, 3 plus 1, 4. So you will have 4 here plus 3j. Okay, plus 3j. Okay, So that is the answer. Okay, so this one is the answer. Okay, okay, so we have calculate. Okay, so we have to calculate our uh, sampled frequency domain signal. So we have xk is equal to what is the value we get? 5 4 minus 3j. Okay, 5 4 minus 3j. Okay, and then we have minus 1. We have minus 1 and 4 plus 3j. Okay, so 1 2 3 4 sample we get. Okay, so you can try, you can check whether you can get you can try whether you can get if you perform the IDFT here, IDFT for this sequence. Okay, for this sequence we should have xn. Okay, but I think you couldn't get the xn here because the samples, number of samples are not enough. Okay, so if you get the 8-point DFT, okay, 8-point DFT, that is enough. Okay, so you have to calculate x0 so on up to x8. Okay, x8. Okay, so here you will so you can use the same definition of complex plane. You can use this circle, the unity circle. Then you have to calculate the endpoint. No, so you are 8-point. So you are going to 2 5. You should have 2 5 by 8 angles, angle separation. Okay, that means 5 by 4, 45 degree. No, okay. So so here we have 1 point. After 45 degree, we have 1 point. After another 45 degree. Likewise, we have this point. Okay. So you have to calculate the coordinate for this point. Okay. So this will be 0, 1, 2, 3, 4, 5, 6 point. Okay. 5, 7. Okay. So this will be so the 0 point will be plus 1 and this will be minus 1. Okay, so this will be plus j and this will be minus j. Okay, so how to calculate this value? Okay, so you know that this is unit circle, so this, the radius is 1. Okay, so this is 45 degree. Okay, so here you can so this coordinate, x coordinate will be 1 cos 45. Okay, so that means 1 cos 45 means 5 by 4 plus sorry, not plus. Okay, and this y coordinate will be 1 sine 45, 1 sine 45. Okay, likewise you can find this point, this point, this point, and this point. Okay, so you have find all the point. Okay, so you can find any value. Okay, so you will have this kind of one. Okay, instead of 4 here. Okay, instead of 4 you will have 8. Okay, you will have 8 here. So if I find this one for 8-point DFT, okay, for 8-point DFT, okay, so you will have xk, capital XK, as 2 plus e to the power, sorry, 3 into e to the power minus j 25 by 8. Okay, you will have 25 by 8. Actually, this one. Okay, this one. Okay, okay. So you will have 25 by 8 instead of this 4, you will have 8. Okay, and you will have this k. Okay, then you will have minus e to the power minus j 25 by 8. So you will have k here. Then you will have 2. Okay, then you will have plus you will have plus e to the power minus j 25 by 8 k 4. Okay, k4. So here k and 4. So instead of this sequence, this series, you will get this one. Okay. So what you have to do, you can calculate, you can assign some value. So this k will be 0, 1, 2, 3, 4, 5, 6, 7. Okay. So there are 8 samples. So you can substitute this value for k, and you can calculate x0, x1, x2, x3. Okay. And you can use the uh, same method. Okay. So say that if you want to calculate e to the power minus j 25 by 8, 15 or something. Okay, so you have to go through this circle. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it will be this point. So you can calculate this value, or you can use Matlab. Okay. Okay. So we will move to the next one also. Okay. So okay. So so I think first part is okay. We have done it. Okay. So we will move to the second part. Okay. Okay. So we have done this one. We have calculated the 4-point DFT. Okay. Again, you have to calculate the 8-point DFT also. Okay. So I think you can do it by yourself. Okay, I will not take much time to this. Okay, so you can use this circle, or you can use Matlab, and you can proceed the same procedure. Okay, so I will leave. Okay, so anyway, if you have any doubt, please call me, or please send me a mail, then I can help you. Okay, if you can't do this by yourself, I think you should be able to do this by yourself. Okay, okay, we will move to the next one. Okay, I think that is also a very standard question. Okay, so this will also a standard question we will have. Okay, so I think if you have go through your note, okay, go through your textbook, this kind of example should be there. Okay, so we are going to consider the finite length sequence. Okay. Okay. So now we are on this. Okay. Now we are going to do this one. Okay. So we have finite length sequence, that is xn. Okay, so it is said that when the n is in n is greater than 0 or less than n minus 1, there will be 1. Okay, there will be 1. So you will have 1, 1, 1 like this up to n minus 1 point. Okay, so this point will be n minus 1. Okay, this will be 0. 0 to n minus 1, you will have 1. Then n is between n1 and n, you will have 0. Okay, so after that you will have 0. Okay, so this will be n. Okay, this will be n1. Okay, so you will have some 0 up to n. Okay, so the last point will be n. Okay. 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 So these are our these are our time sequence. Okay, so we have a finite length sequence. Okay, now you have to calculate the endpoint DFT. Okay, so this is a standard question, I think. Okay, so we have to calculate the DFT, endpoint DFT. Okay, so if we use the definition, xk should be n is equal to 0 to n minus 1. Okay, n minus 1. Xn e to the power minus j to 5 by n k simple n. Okay, so this k should be 0, 1, 2, so on up to n minus 1. Okay, so this is the definition. Okay, I think we have to directly use the definition. Okay, so we have xn, oh, sorry, we have xk. Okay, and this should be 0 to n minus 1. I think here we have endpoints. Okay, and so this is 0 actually. Okay, so all are 0. So if you consider n minus 1, that is okay, no issue. Okay, because we are calculating the endpoint DFT. Okay, because all other parts will be 0. Okay, so you can calculate, you can consider the endpoint 1 value. Okay, actually this is 0 padded. Okay, this is 0 padded sequence. Okay, so we have a padded sum sequence to equal this length into the number of sample. Okay, xk. Okay, so we are padded some 0 here. Okay, so you can consider up to n minus 1, no issue. Okay, so we will consider up to n minus 1. Okay, so we will have n is equal to 0 to n minus 1 xn. Okay, e to the power minus j to 5 by n k simple n. Okay, okay, so we will try to expand this. I think to move forward, we have to expand this. Okay, we have to expand this. Xk is equal to, okay, so you can see that this xn is 1 up to n minus 1. N minus 1. So other will be 0. N1 minus 1. Sorry. Okay. This is N1 minus 1. So this will 1 up to n minus 1. Okay. So we have to calculate actually only that value. Okay. Up to that value. Okay. Because others will be 0. Okay. So you will have like this. Okay. So you will have 1 here. E to the power minus j to 5 by n. Okay, n k. Okay, so this will be 1. Sorry, this will be 0. The n is equal to 0. Okay, I am expanding this. Okay, I am expanding this from n is equal to 0 to n minus 1. Okay, okay, so x0 I will have 1. Okay, because here we have 1 ones up to n1 minus 1. Okay, so here up to n1 minus 1 we have ones here. Then we will have 0. From n1 to n, we will have 0. Okay. So the n value will be 0 here plus 1 e to the power. So this is n is equal to 2. We will have minus j to 5 by n. Okay. K, the n is equal to 2 here plus 1 e to the power minus j to 5 by n. Okay. K, n is equal to 3 here. Okay, plus 1 e to the power minus j to 5 by 4 to 5 by n. K, then will be 4 here. Okay, so you will have this kind of, okay, up to n minus 1. Okay, n minus 1, xn minus 1. Okay, so you will have x0 to xn1 minus 1. So these are all ones. Okay, I think you can understand this. Okay, very simple. Okay, because this is the x. Okay, so this will be x0, this will be x1. Okay, likewise all x2 x3 are also ones. Then this will be xn1 minus 1. So all these are ones. Okay, so that is why I put ones here. So this is x0, this will be x1, this will be x2, this will be this will be x0, this will be x1. Okay, so here 1, this will be x2. Okay, so here it will be 2, this will be x3, so here this will be 3. Okay, and if the n is equal to n is equal to 4, so x4, this will be 1 e to the power minus j 25 by n k 4. Okay, so this will be x4. Okay, so on up to xn1 minus 1. Okay, so here also you will have 1 e to the power minus j 25 by n. You will have k n1 minus 1. Correct? Okay, so other alls will be 0. Okay, because then this xn will be 0. Okay, you can see all others are 0 up to n. Okay, so there are 0 up to n. From n1 to n there are some zeros adding, so we can neglect them. Okay, we no need to write them 0. Okay, this because it is not effect to this series. Okay, so I think you can get the power series here. Okay, you can get the finite power series. This is not infinite, finite power series. Okay, so you can see that it is like this. Okay, so this will be 1. Okay, so this will be e to the power minus j 25 by n 25 by nk. Okay, nk, and it is 1 plus e to the power minus j 25 by n k. Okay, so here it is 2. Okay, actually you can put 2 here like this as a power. Okay, so this is also power and this is also power. When it is a power on a power, it will be multiplied. Okay, so you will have minus j25 by n k2. Okay, this term you will get plus e to the power minus j25 by n. Here it is 3. The k is there, and here it is 3. So you can get total power as 3. Okay, likewise you will have this up to minus j. Okay, we will have this up to minus j 25 by n k n minus 1. So you can put the whole power. Okay, so you will have this kind of power series, but it is a finite power series. Okay, and the number of points are n1. Okay, so you will have n1 component. Okay, so how to find the, so I think you can find the compact version for this series using the Taylor power expansion. No? I think in our first question we have done that one. Can you remember that? Okay, when we so here actually we have found the endpoint DFT for this endpoint DFT for this xn. Okay, I think there we have used that our very familiar our Taylor series expansion, this one. So this will be 1 minus a. Okay. This is now, I think this is very familiar to us, okay, because we have for a Z transformation also, we have used this many times. No? We have used this power series many times. Okay, so we have f a2 plus a3 up to infinity. So that will, we can write it as 1 by 1 minus a using the Taylor series. Okay, so here we have infinite number. Okay, and can you remember that if we want to find the n value, okay, so we can get up to n. After that, we can get out. No, we will we have get out n1. No, if we get out a n1. Okay, can you remember that? Okay, so we have we have used this kind of method, okay, to get that compact value. I think here also we can use the same thing. Okay, so we will go to the question. Okay, I think here it is easy to write. Okay, so now you can see that. Okay, now you can see that. So I will write that power expansion here. So it is look like this, no? A plus a square plus a3, so up to infinity, it should be 1 minus a1. Okay, so you can see that we have to consider up to n1 minus 1 power, n1 minus 1 power up to this. Okay, n1 minus 1 power. Okay, so if I write that, okay, if I write that, okay, so we will have this kind of one. Okay, so we will have 1 plus a square, a3, so on up to a n1 minus 1. We don't know this n value, n1 value, so we will, so we have to write it up to n1 minus 1. Then we have, so this is n1 minus 1. So this, the next component will be a n1. The later components will be n1 by 1. Okay, the next one will be a n1 by 2, so on up to infinity. We will have again 1 minus a, correct? Okay, so we have to get the sequence up to this. Okay, so we have to get rid of these terms. Okay, so we have to subtract these terms actually. Okay, so if I write that terms, okay, so we have a n1 plus a n1 plus 1 plus a n1 plus 2, so on up to infinity. There are very very large number, infinite number of large number. Okay, but we don't know the value here. Okay, we don't know the value here. Okay, so what we have to do? Okay, so you can see that if this is a0, if this is a1, if this is a2, so on up to infinity, we have a Taylor series solution here. Okay, so we have to try, we have to try to make this series in that form. Okay, so easily we can do it. Okay, so what we have to do is, if we get out a minus n1 here, okay, if we get out a in minus n1 here, so you can see that if I multiply these together, okay, if I multiply these together, this term will be a minus n1 plus n1. Okay, so this will be a 0, and this will be a minus n1, a n1 plus 1. So n1 cancel out, you will have a1 here, and the next one, So this n1 cancel. So you will have a2. Likewise, you will have a3. Likewise, you will have a4. So there are some value up to infinity. Okay. So this will be again. Okay. So this will be again 1 minus a. No, correct. Okay. So this will be again 1 divided by 1 minus a. Okay. 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 So if I take out this one, n1 minus 1, okay, n1 minus 1, okay. So we will have a n1 plus a n1 plus 1, a n1 plus 2, okay, up to infinity, okay. So if I multiply it by this a n minus 1, okay, so if I simplify this again, I will have a plus a0 plus a1 plus a2 plus up to infinity, okay. So I will get the same result, no? Here again I will get 1 minus a minus a, okay. So here again I will get 1 minus 1 divided by a minus a, correct? Okay. So if I multiply this value from a n1 a minus n1, again I will have a0 a1. Okay, I think if I write here, you can understand it is easily. Okay, I think you can understand because we have done this. Okay, previous for in question 1 we have do this. Okay, so you can see that if we multiply this by a n minus 1, again you will have here a0, a1, a2, a3, so on up to infinity. Okay, so that is again we can write it as a 1 minus a. Okay, so this will give again this one. Okay, so it can be written as 1 by 1 minus a. So this also can be written as 1 by 1 minus a. Correct? I think you're clear. It is clear for you. Okay, so now I have to find this value only, a n1 plus 1, n1 plus 2, so on up to infinity. Okay, so what I have to do is, if I divided this by a n minus 1, and if I divided this side also by a minus n1, okay, so this one will cancel out. Okay, so we will have, okay, so I will write it here. So we will have this kind of sequence, a n1 plus a n1 plus 1, so on up to infinity. Okay, so that means this part. Okay, and it will be equal to so here I have divided this a minus n1 by a minus n1, so this also should be divided. Okay, a minus n1, so it so this is a minus n1. So when if I put it here, so this minus value will be cancelled. Okay, so I will have a n, okay, a minus a, okay, a n1, a n1, a 1 minus a. Okay, so I think this also we get earlier. Okay, so if I subtract this, okay, if I subtract this from this, okay, so you can see that if I subtract this from these terms will be cancelled out. A n will cancel out, a n minus cancel out, so all things are cancelled out. Okay, so I will get only up to this level. Okay, so finally I can get a plus a square plus a3, so on up to a n1 minus 1. So I have to subtract this 1 divided by 1 by a, 1 divided 1 by a minus a n1 divided by 1 by a. So if I get the common denominator 1 by a, so here we have 1 minus a n. Okay, so this is the result. Okay, so we can write this finite sequence also as a compact version using the Taylor series. Okay, we have to do some mathematical manipulation and we can get this we can get this compact expression. Okay, so if I apply it to here, okay, if I apply it to here, I will have xk. Okay, so I will have xk as 1 minus a is e to the power minus j 25 by n k. Okay, e to the power minus j 25 by n k in 1. Okay, divided by a is this one, 1 minus e minus j 25 by n. Okay, uh, so this is the expression I got. Okay, okay, it is in sign form, no? Okay, I think using the Euler formula we can get this result. Okay, so you can use the Euler formula here. Okay, so if I use the Euler formula, okay, and you will have 1 minus, so you know the Euler formula. Okay, you know the Euler formula. What is the Euler formula? So Euler formula is this. Okay, we have e j theta. We can write it as cos theta plus j sin theta. Okay, so here you will have a minus j theta, then you will have it as cos theta minus j sin theta. Okay, so then you can convert this e to the power value to cos theta j sin theta. Okay. Then okay, here we have only sine value, no? Okay, so we have only sine value. Okay, so if I subtract, we will get the sine value only. E to the power j theta minus e to the power minus j theta, we will have minus minus 2j sin theta. Okay, so we will have this one. Here it is minus 1. No? We have minus 1 also here. So 1 minus here, and this will be minus Okay. Uh, Let me write this in this form. Xk is equal to minus. So here e to the power minus j 25 by k n1. You see here also we get out this kind of one. No? Okay. We have get out this one n1. Okay. n1 n. So here we have to get this. If we get e a phi n1 minus 1. So here we have a term. Okay. So to take that term, okay, I'm not sure my approach is correct or not. Okay, we will try it. Okay, I think it will be okay. Okay, so you can see that here we have e to the power minus j term minus j 25k. Sorry, 5k. There is no 25, no. J 5k n1 minus 1. Okay. J 5k n1 minus 1. Okay, so j 5k n1 minus 1. Okay, so we have this term, and if I write another one minus j, no, this should be n, then I will get this will be n1 minus 1 n. It will be complicated. Okay. Okay, so you can see that we will have this kind of one. Okay, we will have this kind of one. Okay, so it is e j theta minus e minus j theta is equal to 2j sine theta. Okay, and you can see that we have to convert them sine terms now. Okay, so let's try to get this using the time sine terms. Okay, so if I get uh, so so here it is 1 minus value, no. Okay, so to make that one I will keep out this ej theta value. Okay, so I have e minus j theta. If I get this ej theta here, okay, so this will be 1 and this will be 2j theta, no? Okay, so if I 1 minus e 2j theta and ej theta. So if I multiply this ej theta, this term have okay, and ej theta minus e2j theta, so minus 2j theta plus j theta, you will have minus j theta. Okay, and this is equal to 2j sine theta. Okay, 2j sine theta. So it is somewhat similar, no? 2j sine theta. So we will see. Okay. So I will apply this result. Okay, we will try to apply this result to this. Okay, so this is okay, no? No, there is no any issue. So e j theta is cos theta plus j sine theta minus j. So I divide, if this is 1 if this is 2, I just subtract 2 from 1. Okay, so I have 2j sine theta, ej theta, ej minus theta. Okay, so on minus, I get out this ej theta. Okay, so I will have this. Okay, so I think it is okay now. Okay, so if I apply this result to this one, okay, so I have xk here. Okay, so okay. So you can see that 1 minus e2j theta, okay, 1 minus e2j theta is equal to 2j sine theta divided by ej theta. No, 2j sine theta divided by ej theta. I will apply this value because here we have only 1 minus e value. Okay, so this. Okay, let me write it clearly. I think if you go through the lecture book, I think if you have go through the notebook, okay, you will get this. Okay, I don't know, maybe simplification is not available there. Okay, so you can see that this result is okay now. So I have only 1 minus e terms. Okay, so here I take 1 minus 1 2j theta is equal to 2j sine theta divided by e to the power j theta. Okay, so I will apply this result. Okay, I will apply this result to this one. So you can see that 2 value is here. Okay, so 1 minus e 2j theta. Okay, so 2 here minus j here. Okay, so this is minus j 2j. Okay, so this will be theta. No? This will be theta. So what is the theta? 5n by k. 5n by k, and this n1 also is here. Okay, so you know that. So this is power of n. Okay, so if I, so this is e j25 k. So n1 power is there. So so you know that power to the power will be multiplied. So we have n1 here also. Okay, so this, so I have take this minus 2j out. Okay, if I take this minus 2j out, okay, so I take this out, so this will be corresponding to theta. No, this will be corresponding to this theta. Okay, this theta corresponding to this. Okay, so I can use this result. Okay, so I can write it as 2j sine theta. Sine theta means 5n k n1. 5 k n1 n. Okay, so this will be my theta. Okay, okay, and it should be divided by this should be divided by, okay, and this should be divided by e j theta. Again, theta is 5n k n1. Okay, 5n k n1. So this will be my theta. Okay, okay, so I apply the same result for the lower part also. Okay, so I will put the multiplication value here. So here it is a division. Okay, so it should be 1 by multiplication. Okay, so okay, so I write this here. Okay, so I write it here. What is that? 1 minus e minus 2j theta is equal to 2j sine theta, 2j sine theta divided by ej theta, divided by ej theta. Okay, now we are going to use this result with this one. Okay, now we have already write this term using this result. Now I am going to write the lower terms also using this result. Okay. So it should be 1 by, so here I use the multiplication. So here we have a division. So it should be 1 by, so multiplication, if I put the multiplication, it should be 1 by the value. No? So here 1 by, so you can see that here also 2j value. Okay. So in this, for these terms, for these lower terms, theta is corresponding to this 5nk. Okay. So this will be corresponding to the theta. Okay. So we have 2j sine 5nk. Okay. 5nk divided by j theta. So it is divided, then you can get it here in upper. So you have e j theta is nothing but 5n by k. Okay. So you can keep that 2j cancel out. Okay. So xk we will have, okay. So this sine 5k n1 in sine 5k n1 divided by n divided by sine 5nk sine 5nk. Okay. And here, so you can see that this, here we have a division. Okay. So if the division is there, the power will be subtract, no? So I get E here. So yeah, so for both signal J is common. Okay, so I get out the J. Okay, and also this 5nk also common. Okay. So this theta is 5k n1 n. Okay, so here n1 is also there. Okay, in these terms n1 is there because this is the theta 5k n1 n. So ej theta 5k n1 n1 divided by n. Okay, so I have j 5 is common and k is also common and n is also common. So I get that one. Okay. So in 1, so this will be -1. No, correct. I just subtract these two because I just subtract the power. Okay. If I subtract the power, we will have e to the power j 5n kn1 minus 5n kn. Okay. 5nk. Okay. So I get j 5nk out, j 5kn out. So we will have n1 minus 1. Okay. So we will have this one. Okay. Actually, this is the answer, I think. No? Let's see. I think if I get this one, it is missing. Okay. I think okay, answer is 25 n1 and 2 sorry, sine 5k n1 n. Sine 5k n1 n. So this one, no? Sine 5k n1 n, correct. Divided by sine 5k n. Divided by sine 5k n. So this one, okay. And it is e to the power j 5k n n1 minus 1. E to the power j 5k n n1 minus 1. E to the power e to the power 5kn n1 minus 1. Okay, so here minus sign is there, and I think here also minus, we forgot the minus sign, no? Yes, we forgot the minus sign because here the minus j is here. Okay. No, minus j we get rid of, no, because this is e to the power minus j2 theta. No? Okay, so here there is no minus sign. Okay. So what is happened to the minus sign? N1. Okay, okay. Sorry. Here we have n. Here we don't have n, no? Okay. Because this is sine 5n by k. This is theta, and here also j5n k. Okay. 5n by k. There is no n. So n1 is here. Okay. So so this is 5n k minus 5n k n1. Okay. 5k n1. Okay. So this will be, if I get out j5kn, okay, so it is equal to this j5kn. So here it is 1. Okay. And so 5kn n1 is here, so it should be minus n1. Okay. So here 1 minus n1. So you can uh, get out the minus value, and you can write it as n1 minus 1. Okay. So that is the way. Okay. So you have get this. Okay. So here this one you have get. Okay. And the k is equal to 0 in 1. So k is equal to 0. This will be n1. I think that is okay. No? So you can apply the k is equal to 0 here. Okay. If you apply the k is equal to 0 here. Okay. So this will be 0. E to the power 0 will be 1. Okay. So here we have 1. No? Okay. So k is equal to 0. It will be 1. I'm clear with this actually. Okay. Because if you apply the k is equal to 0, it should be 1. Okay. How it becoming 1? Is the issue. No, here the sine 0 is 0, sine 0 is 0. So if I directly substitute k here, okay, x0, okay, so it will be 0 divided by 0, and it is 1. Okay, so this 0 and 0, so this is not defined. Okay, this is not defined. Okay, so we can't apply the k is equal 0 value to here. Okay, because we get 0 divided by 0, so this is undefined in maths. Okay, So we have to use another method actually to find the zeroth component, zeroth value. Okay. So I think the k is equal to 0. Okay. Actually, you have to calculate it here. Okay. Because if we get the compact form, okay, this will be our compact form no? Okay, so you can see that if I apply 0 here, 0 here, and 0 for this one, okay, so I have 1 minus 1, 1 minus 1, then 0 divided by 0. So this is not defined. Okay, so we can calculate it in this compact form when the k is equal to 0 case. Okay, so we have to use this before the before we doing the compact. Okay, we have to use this one to calculate x0. Okay, so you can see that if you put x0 here, you will have 1 here. Okay, and this terms also will be 1. Okay, so if x0 k is equal to 0, okay, x0, so you will have 1 here, and this is also k is 0, so you will have 1 here. This also k is 0, you have 1 here. This also k is 0, you have 1 here, because e to the power 0 is always 1. Okay, so likewise you have up to this level, you have 1 again. Okay, so this will be your n minus 1 component, so this will be your 0 component. So you will have 1 1 1. There are n1 n's. Okay, you are adding them together, then you will get n1 again. No, you will get n1. So if there are 10 ones, if you add them together, then you will have 10. If you are 100 ones, if you add them together, 1, 2, 3, like that, you will get 100. Likewise, if there are n1 terms, if you added them together, you will, if you added this one together up to n1, you will have n1. Okay. So I think this one is also correct. Okay. So this is okay. Okay. Now we are asked to plot the magnitude and phase spectrum. Okay. So actually, I think you have the idea about this magnitude and phase spectrum. That is not very big concern. Okay. Because we can calculate x0, x1, x2, likewise, these are up to xn. Okay, if this is endpoint, we can calculate. Okay, so you know that all these are some complex value, x plus iy. Okay, all these are complex value. Okay, so sometimes this x is 0, and sometimes these are totally imagination value, and sometimes this is y0. So these terms can be totally real value. Okay, but anyway, we can uh, express this as a complex number. Okay, because sometimes it may be a complex number. Okay, so any number can be represented as a complex number. If it is a real number, only thing is this y is equal to 0. Okay, but it is still, it can be expressed as a complex number. Okay, I think in Matlab we get it, no? So you can see that. Okay, so this one is totally imaginary number, because the real part is 0. Okay, and this one you can see we have only real parts, and total part is the imaginary part is 0. Okay, but still it can be expressed as a complex number. Okay, so you can see that if I tell you the summary, this x0, x1, these samples are complex numbers. Okay, so if it is a complex number, you can calculate the phase, the magnitude of this complex number. This will be the magnitude. Okay. Uh, this will be the magnitude, or we can say that xk magnitude. Okay. So this will be the magnitude of xk. Okay. And also you can find the phase also. It is y divided by x tan inverse. So this is the phase of xk. Okay. So likewise, for this every xk value, you can calculate the magnitude and phase. You can calculate the magnitude and phase. Okay. So this x0 has some magnitude. Okay, and has a phase. This one also has a magnitude and has a phase. This one also has a magnitude and has a phase. Okay. So if you put, if you plot the magnitude of this xk, okay, these values, okay, the magnitude of this value with respect to k, you will have some value like this. Okay, we don't know, k is equal to 0, 1, 2, and k can be -1, -2. There you will have some magnitudes. No, we don't know what are the magnitudes. Any magnitudes you can get. Okay. And in the same manner, this is called the magnitude plot. Okay, this is called the magnitude plot. In the same manner, you can plot the phase of this xk. Okay, of this value, phase of this value. Okay. And you can plot them against the k also. Then also you will get some phases. Okay, so here 0, 1, 2, k is equal to 2, 3, 4, so on up to infinity. -1, -2, -3. Then you can plot the phase corresponding the phase corresponding to each k value. Okay, so this will be the phase plot. Okay. Now we are asked to draw the magnitude plot. No. Okay. Now we are asked to draw the magnitude plot. So using the Matlab, actually, you can easily plot the magnitude plot. Okay. So how to plot it? Okay, you can use this result. Okay, you can use this result. Actually, if it is k, you have to put it as n1. Okay. So I think here you have to, if you type in this Matlab, okay, you will have some, you have to type more. Okay. Anyway, you can type this one, no issue. Okay. But rather, I think I can directly type this one. Type this one, because this one is very compact and I can type it very easily in Matlab. Okay. So I will use this one. Okay, I will use this result. Okay, okay, that is xk equal to 1 minus e to the power minus k to 5 by n km kn n1 kn1, sorry, n is not there now. It is we have converted it to the k domain. So it is n1 25 by n k n1. Okay, not n. It should be n1 k n1 k n1 divided by 1 minus e minus k to 5 by n k. Okay, so I will type this one. Okay, so you can see that this is a complex value. Okay, so if you put some value for this 0, n1 and n, so it will be to the power minus j some value. Okay, so this will be a complex value, and this also will be a complex value. Okay, so you can simplify this as like this, in this form, x plus iy. Okay, so you can calculate the magnitude related with the k values. Okay, related with the k values. Okay, then you will have this you will have magnitudes, some corresponding magnitudes and corresponding phase. So you can plot them against the k value. Okay, so you can easily plot the magnitude and phase plotting. So you will see. Okay, so we are asked to calculate it for. So you can see that we are asked to use N1 as 7 and N as 30. Okay, so you can calculate. Okay, so N1 is 7. Okay, and N is 30. Okay, it's 30. Okay, now I can calculate the magnitude value for xk value. First, I have defined the k value. Okay, so k should be, I will put here 1 to, no, I think it is better to put 0 to 30 because n is 30. Okay, n is 30. So I have to calculate it up to k should be 0 to n minus 1, no? N minus 1. Okay, k should be 0 to n 1 minus 1. Okay, so this will be 2. Okay, so you no need to put the increment. Okay, if you put like this, say we will have one increment. Okay, for example, if I run this, okay, so you can see that, okay, we will have 0 1 2 3 up to 29. Okay, correct. K is from 0 to n minus 1. Okay, so these are the k values. Okay, k value should be 0 1 2 3 so on up to n minus 1. Okay, so I put this k value. Okay, then I have to calculate the magnitude of the x value. Okay, so if I calculate the x value, okay, let's say that xk, okay, xk value. Okay, so I will use that identity. It will be 1 minus e to the power minus okay, so I will write this in a piece of paper. Okay, I can also, so it will be xk will be 1 minus e to the power minus j25 by n kn1 divided by 1 minus e to the power j25 n k. Okay, minus j25 n kn1 1 minus e to the power minus j25 by n k. Okay, so I have written it on a paper, piece of paper, otherwise I have to look here and there every time. Okay, so it will be minus j. Okay, minus j. J I can write this as 1i, imaginary parts, imaginary number, and it should be multiplied by 2 pi. Okay, 2 pi, and also multiplied by k. Okay, and again multiplied by n1, and it should be divided by n. Okay, so this is the expression. Okay, so I will put another bracket here also. Okay, and because there is a division, I will put the bracket for this total value also. Okay, so it should be divided by, okay, so I will copy this. So what is the denominator? Denominator is 1 minus e to the power minus j25 by k 25k divided by n. There is no this n1 part. Okay, so I have so, so this will be my x value actually. Okay, so this will be my xk value. Okay. Okay. So if you run this, okay, if you run this, okay, you will have only one because here still we didn't put the for loop. Okay, so so maybe no, this xk can be will be so this 0. If I put 1 here, okay, if I run this, let's see what happens. Okay, you can see that for xk, okay, xk actually, so here the xk is calculated when this k this one, okay, I get it. Okay, now it is okay, no? Okay, so because you can see that this is array, okay, this is array, and here this one also should be array. Okay, so corresponding so here the corresponding k value, this k, xk is calculating corresponding to this k value. Okay, so there is a vector, there should be a vector also. Okay, so when we are manipulating vectors, sometime if the division or multiplication is there, we have to put this dot value here. Okay, so it will act as a dot product of a vector. Okay, otherwise sometime it will not give the correct answer. Okay, so we have to put when we are multiplying or dividing, if we put the dot here, it will be safe. Okay, so you can see that once we so here we have a k array, so it is some k values there from 0 1 2 3 up to 29. Okay, and we have calculating corresponding xk value here. Okay, so this xk value, you can see those are complex value. Okay, those are complex value. Okay, so we have to plot. We no need to plot the. So we have calculated the magnitude, and we have to plot it with respect to k. Okay, so so easily you can use plotting. Okay, actually before the plot we will use stem. Actually the stem command is the better one. Okay, so you have to calculate the absolute value of this xk. Okay, if you put this value, it also will calculate the absolute value when it plotting. Okay, because we can't plot imaginary numbers in xy coordinate. Okay, there are no imaginary parts. Okay, so the only the magnitude or real part will be considered. Okay, I don't know which one may be considered. Real part on the magnitude will be considered if we put xk here. Okay, but if we put, so the independent variable is k here, that is okay, And if we put absolute xk, I think that will be okay. Absolute xk, okay. So you will get so on this. We have to put another buffer t. So now let's see what happened. Okay. Okay. Okay, we will get this kind of one, no? Okay. I think it will be like this, okay? I think it will be like this. Anyway, if we plot this, see what happened. Plot. Yeah, I think there is no any fluctuation. I hope this kind of graph, okay. Maybe this may be also okay, okay. I'm not sure, but I hope this should be like this, okay. Anyway, this will be your magnitude plot, okay. So if you use the stem, okay, stem, it will be your magnitude plot, okay. And here we didn't plot uh, k is equal to 0 value, okay. Uh, so you can use 0 here, okay. You can use 0 here, and you can put conditional value, no? Conditional statement is equal to 0, xk equal to n1, okay, xk equal to n1, okay. So that is our one, no? Else this one, okay. So we have to end. So if I write this, I think there is no issue. Yes, yes, this should be capital K, okay. So I will get the same result, okay. Okay. So this 0 point should be here, okay. It should be here, but it is not plotted, no? So what is the xk value? Here you have, it is said that it is again this one. Why it is not calculating? What is the problem? Here also we didn't get the there's an error with this code actually. I can't understand what is there. There is a description. Okay. Variable k might be set by a non-scale operator. It is a non-scale operator. You can assign value. No? You can see. You can assign value directly in this way. Okay, but no. So I think if I put the for loop here, no issue. Okay. Because sometimes it cannot identify the location index. Okay. So if I let me put the for loop here. If k is equal xk xk and this also will be xk. And because maybe sometime now you can see that that error is disappeared. No. Okay. Uh, So we asked to pre-locate in for speed. Okay, so we can pre-locate it. That means we can assign empty, not empty value. We can assign. We can set this xk value. Okay, so it is 1 to n minus 1. No, n 1 to n. Okay, so this is the, so I have, so here I'm doing nothing. I just create the zero array to fix the number of xk. Okay, so we have there are 30 zeros. Okay, so xk is xk, the length of xk is not changing. Okay, so here, so that is called pre-locating. We have done it. Okay, so I think now it will be okay. It should be okay. Yeah, you can't get the zero value. Okay, because index cannot be zero. Okay, so what is the solution for that? So if I put k plus 1 here, let's see. I have to assign the k here also. Change this. So this, so I put k. Okay, and okay, no, I think it should be okay. So because if I put the for loop here, it is looping. So finally, it is not creating a k array. Okay, it is creating. It is give only k value. So this is the final k. That it will be 29. Okay, so that should not be happen. Okay, so we have to do it. So we have to have an array with 30. Okay. Then I think it will be okay. This should be, sorry, this should be up to n minus 1. Okay, this k should be up to n minus 1. Okay, so here I have defined the k value. Okay, okay. Now I think it will be okay. Let's see. Okay, now you can see that we have 7. Okay, so we get the magnitude plot. Okay, and if you want to plot the phase plot, okay, you can use the command. I can't remember. I think it is angle or something. Okay, let me check. Okay, you can go to the Google and yes. Matlab or something. Let's type like this. It will be angle. No? So it will be angle. Okay, so if I plot the angle, okay. So let's see how it like. So I think angle is correct. This way we have to get, yeah. Okay, so if I plot it, okay. Yeah, this kind of variation is there. Okay. So that is that. Okay. Okay, so we will move to the question again. Okay, so this is how to plot the magnitude and phase plot using Matlab. Okay. If I go to the question again. Okay. This one. Okay. So we have to do the same thing. Okay. So we have to calculate the 4-point DFT using the this is called matrix form, no, linear matrix transformation. Okay. So I think that one also very easy. We can do it. Okay. I think you know that. Okay. So you can see that the same thing. Okay, here. Okay. So you can see that. So in the case of 4-point DFT, okay, this is the 4-point DFT, no? So we asked to do it for a 4-point DFT, okay? So this is the 4-point DFT, okay? So we have xk value, okay? We have xk value, and this one. So these are xn value, no? These are xn value, okay? These are xn value. You know that this is x0, this is x1. X2, there is no x3, x4, likewise. These are xn value, okay? So if I write this equation in matrix form, it will take like this, no? It will take like this, okay? So this will be x0, x1, x2, x3, so on, is equal to, there is x0, x1, x2, write it in the same line, okay? So I have x0. Okay, so I'm going to write that. So we have like this way, no? E to the power minus j 25 by 4 and k1 minus e to the power minus j 254 k k1 plus e to the power minus j 254 k. This is 0, this is 1, this is 2, this will be 3, this will be 4. Okay, so I think this is the series, no? K 25 by 4k minus 1 minus 1 4. So I'm going to write this equation in the matrix form. Okay, so you can see that these are x values. So this will be x0, this will be x1. Okay, so this will be x2. So this is, there is no x3, and this will be x4. Okay, so I have x3, x1, x2, x3 equal okay, x3 and x4. There is actually for a PowerPoint one we have to get up to x3. Okay, I think there is a error with discussion actually. Okay, so you will have the matrix. Okay, and you will have here x0, x1, x2, x3 like this. Okay. So you will have this kind of, so this is the matrix notation. Okay. So you can see that okay. So this will be xn1. Okay. Okay. So 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 you can see that this will be x n by 1. Okay, so this is number of rows and this is number of columns. Okay, so we have 4 by 1 matrix. We have 1 column and there are 4 rows, 1, 2, 3, 4. Okay, and so this is n by 1. Okay, so there are n rows. Okay, so we have n rows. Okay, 1, 2, 3, 4 rows. Okay, and there is one column, only one column. Okay, and this will be n by n matrix. Okay, so there will be n rows and n columns, and n rows. Okay, so we will have this kind of matrix. Okay, so what is this matrix actually? It is this value actually. Okay, so it is e to the power minus j 25 by 4. Okay, k. Okay, k, and n is also there, no, because here n is 1, here n is 2, n is 3. Okay, so n is also there. Okay, so actually this is we get this as w. Okay, not total one. Okay, only this one. Okay, only this one we consider as w. Actually, if it is 4 point, we consider it as w4. Okay, and we have kn here, so we have kn here. Okay, so this value we have to calculate, we have to put it here. Okay, uh, so I think it is also very simple. Okay, so you can see that. Okay, here we have here there should be 4 rows. Okay, 0, 1, 2, 3, 4. Okay, 5 rows. That's a problem actually, because this length cannot be 4. Okay, this length cannot be 4, it should be 5. Okay, so we have to at least calculate the 5-point DFT. Okay, 5-point DFT. Okay, so we will do it up to 3. Okay, because we have to find the 4-point DFT. No, so no, let's put up to 4. We will see what happens. So here also x4 is there, and here x4 is there. Okay, so this also will be 0, 1, 2, 3, 4. Okay, so if I write this matrix, you can see that this will be the n value. Okay, this will be the n value and this will be k value. Okay, so that is the normal standard. Okay, this will be the n value and this will be the k value. Okay, so you can see that here we have w in, all are zeros. Okay, all are zeros. W0, W0, and if you get this one again, k divided k into n. Okay, so here in this row the k is 0, so all will be 0. Okay, and if you consider the first column, the n is 0 for all value. Okay, so this column also will be 0. So this will be 0, this will be 0, and this will be 0. Okay, so if you get this one, okay, if you get this one, so you can see that n is 1 and k is 1. Okay, so you have n1. Okay, so here n is 2, k is 1, so you have n2. Okay, so here, okay, so I will write it here. So we have n value here 0, 1, 2, 3, 4, and we have k value here. Okay, in this way 0, 1, 2, 3, 4. Okay, so for this all will be 0. I will not use this n. Okay, I will not use this n. I will write this value also. Okay, 0 is 0, is 0, and this will be 0. Okay, and here also 0, this one also 0, this one will be 0. So you can see that. So I just forget this 4. Okay, I use only this one. Okay, so here w k is equal to from here. Okay, 0, 1, 2, 3, 4. Okay, so this the k should be, because we start our matrix from here. Okay, here and here. Okay, so this will be 0, 1, 2, 3, 4, and this will be 0, 1, 2, 3, 4. Okay, so this will be w1. Okay, because n1 k is 1. Okay, so this will be w2 because k1 n is 2. This will be w3, this will be w4, and this will be w n1 k2, so it is 2. Okay, so this will be 2 by 2, you will have 4. This will be 3 by 2, you will have 6. This will be 4 by 2, this you will have 8. Okay, so if you consider this one, you will have here w3 1 by 3. So here 2 by 3 6. Here you have 3 by 3 9. Here you have 4 by 3 12. Okay, and here in w in this 4, in the fourth row, so you will have 1 here because n1 k4. So you have 2 by 4, that is 8 here. W 3 by 4, you will have 12. W 16. Okay, so you have to calculate this one. It is very simple. Okay, you have to calculate this one. You can use the that circle. Okay, so these are the point. Okay, so it will be +1, -1, plus j, minus j. Okay, so this will be the 0th one, this will be the first one, this will be the second one, this will be the third one. Okay, so w0 is this one. Okay, 0, n is 0, w0 is this one, so that is 1. Okay, so here all terms you will get 1. Okay, for all terms you will get 1. Okay, so you will have 1, 1, 1, 1, 1, 2, 3, 4, and here also you will have 1, 1, 1, 1. Okay, and what is this one? W1, that is this one, so it will be minus j. Okay, and this is W2, that is this point, it will be -1. This will be W3, it should be this one, so it will be plus j again. Okay, and this will be 4, that means 0, 1, 2, 3, 4, so it will be +1 again. Okay, and if you consider this one, so this is this one, and if you consider this one, W2, that is this one, minus j, and here W4, so 1, 2, 3, sorry, 0, 1, 2, 3, 4, that is +1, Okay, and here W6. Okay, W6. So you have to calculate 6.1, 0, 1, 2, 3, 4, 5, 6. So it will be -1 again. Okay, so this is W8. So you will have to calculate 8. 1, 2, 3, 4, 5, 6, 7, 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Again this one, +1. Okay. Likewise, you can calculate all the value. Okay. And the 12 will be W12 will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It will be +1. Okay. So this W12 will be +1. And W16 will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Again, it is this one. Okay, likewise, you can calculate any value. Okay, I think the ninth value you have to calculate. You can calculate 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This point minus k. So that is W9 minus k. Okay, so you can calculate this for whole value. Okay, I think this is called the twiddle factor. This is called the twiddle factor, and this is the twiddle matrix. Okay, so if you have many points, okay, so this twiddle factor method, this matrix method is much easier. Okay, and so I think that is enough for that one. Okay, so we will see the next one. Is the next one. We will see calculating the 4-point DFT. So this one we have done, and we have to do this one. See the DFT. So here we are given a continuous function. Okay, and this is also UT. Okay, so we have a continuous function to the power minus t. Okay, and so how it is.